Okay, when we talk about the angles of a triangle, usually we're talking about what are known as the interior angles. So if I said angle A in the triangle, that would be this angle right here, angle B, and then angle C. But if you extend the sides of a triangle, there are also exterior angles. For example, if I extend side AC, then this angle right here is an exterior angle. It's outside of the triangle. Okay, I could have extended side AB, and then this is an exterior angle as well. These two angles, by the vertical angles theorem, are actually congruent angles. I could extend side AB for an exterior angle for angle B. I could extend side CB for an exterior angle for angle B. I could extend side AC basically to the right, and then that would be an exterior angle for angle C, and so on. So there's interior angles, and then there's exterior angles for triangles as well. So I think most people actually already know theorem 5.1, the triangle angle sum theorem, or the textbook actually refers to it as just the triangle sum theorem. We're not adding triangles, we're actually adding the angles of the triangle, so I will refer to it as the triangle angle sum theorem. But I have my triangle ABC. Again, for the triangle angle sum theorem, it could even be more specifically called the triangle interior angle sum theorem, but I reflected it. Here's angle A, angle B, angle C. If I took each of those interior angles, I know you can't see what I'm doing right now, but I'm just ripping up the triangle. Here's angle C. If I add angle B to that, here's angle B without even having to use a protractor. I don't know the individual measures of the angles, and I add angle A to it. All three of those angles together basically make a line. I could have done this with any type of triangle. What it appears to be in my diagram and then my drawing as well is possibly a scalene acute triangle. Maybe you think it's an isosceles acute triangle, but I could have done it with a right triangle, obtuse triangle. It doesn't matter. All three of the interior angles of any type of triangle, their sum, that's why it's a triangle angle sum theorem, is 180 degrees. So the sum of the three interior angles of a triangle is always 180 degrees. So the sum of the three interior angles of any triangle is 180 degrees. Okay, that's why specifically you can only have one right angle in a triangle. If you have one right angle in a triangle, that's 90 degrees. That leaves 90 degrees for the other two angles. If one of the other angles was 90 degrees, you can't have a third angle in a triangle be 0 degrees. And then really the same thing holds true for an obtuse triangle as well. But that's a triangle angle sum theorem, or sometimes I might just refer to it as just the triangle sum theorem, even though we're not adding triangles, we're adding the angles. Okay, and then theorem 5.2 is the exterior angle theorem. So in this case, for triangle ABC, I extended side AC, and then angle 1, the way that I numbered it, is an exterior angle. So let's go through this process here. Angle 1 and this angle, angle C or angle ACB, I'm going to call it angle 2. Those two angles form a linear pair. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And then it's also the case, I'm going to label angle A, angle 3, and then angle B, angle 4. So by the triangle angle sum theorem, the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is also 180 degrees. And then what I could do is set these two expressions equal to each other. Measure of angle 1 plus a measure of angle 2 is equal to the measure of angle 2 plus a measure of angle 3 plus a measure of angle 4. And then the reason why you could do that is the substitution property. Or some of you might use a transitive property. I forgot angle there, sorry. But here's what we could also do. Subtract the measure of angle 2 from each side. Those will just cancel each other out. The measure of angle 1, this exterior angle here, is equal to the measure of angle 3 and the measure of angle 4. That's the exterior angle theorem. The exterior angle theorem states an exterior angle of a triangle is equal to the sum of what are called the remote interior angles. So angle 2 is an interior angle to angle 1. it's next to or adjacent to angle 1. So it's an adjacent angle. The remote interior angles, just think about like a remote for a TV. The remote is because you're far away. You don't want to go up and like change the channel to the TV. And with today's TVs, I don't even think that you can actually physically change the channel on the TV itself. But you have a remote because you're not next to it. So angles 3 and angles 4 are the remote interior angles. So that's theorem 5.2. Like I said, the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. Again, the remote interior angles are the non-adjacent interior angles, plural. So there would always be 2 remote interior angles for any exterior angle. For example, if I extended side AB, I call this angle 5. Angle 5 is an exterior angle. The remote interior angles for angle 5 are angles 4 and angles 2 because those are non-adjacent to angle 5. So that's the exterior angle theorem.